Okay, so in this question, it seems like they're giving you a lot of information, but what's already written here is already on the diagram anyway. So part A is saying find the vector p to b in terms of the vectors a and b. So we can't go directly from p to b as is always in these questions. So what we can do is kind of take a detour a little bit. So p to b, from p to b, if I can let me write. Okay, my arrow can go there instead. This is equal to, well, we can go from P to A instead. So let's go P to A first, and then go from A to B. So we still end up where we want to at B, just taking a little bit of a detour. Okay, so P to A, we're going P to A, but it's given us the vectors for A to P. The vectors for A to P is going to be 2B plus this B here. So the vectors A to B is 3B in this direction. But we're going against that direction. We're going the opposite way. So we want to take the negative of that, which is negative 3B. And then when we're at A, we want to go from A to B, and we're going in that direction. It's just going to be the vector A. So that is P to B. It's negative 3B plus A. And the next part is, it says that B is the midpoint of A to C, and it says M is the midpoint of P to B. Show that NMC is a straight line. Okay, so NMC, which is here, so N to M to C, this is a straight line if we can prove that M to C, the vector M to C, is a scalar multiple of the vector N to M. If that is the case, if M to C is a scalar multiple of N to M, it means that they are going the same direction. So N to M and M to C, it will show that they are going in the same direction. So let's try and prove that then. So the vector N to M is going to be, we can't go directly from N to M, but what we can do is go from N to P and then go from P to M. Okay, so in the question it's given us that N to P is the vector B, which is here. So that's the vector B, underline it just to show you it's a vector. And then P to M, we don't know what P to M is, but we know what P to B is. And we also know, because it's given in the question, that P to M is the halfway point of P to B. So I'm going to have half P to B, the vector P to B, which we do know. That's the first part of our question. So we've got vector B plus half the vector P to B, which we said was negative 3B plus A. So if I expand this, I get B plus, so take away 3 over 2B plus half A. And if I simplify this, I would get of A minus B. Okay, and now we've done N to M. So the next part is to find the vector M to C. So M to C, can't go directly from M to C. What we can do is go from M to B first. So M to B, and then go from B to C. So like last time, M is the midpoint of P to B. We go in the same direction still. So we want half of P to B. So very similar to the last question, the last part. And then we want B to C, which we can do after. So half P to B, we have half of negative 3B, sorry, plus A. Now, this BC part, it says that B is the midpoint of A to C. We have the vector A to B, and if B is a midpoint, then this distance here, this size, this distance here, B to C, is the same as A to B. And because it's a straight line, it's going in the same direction, so we can say that this vector here is also going to be A. So we can say BC is the vector A. If I just expand and simplify this, I would get -3/2 B plus half A, then plus another A there. And I would get it, if I fully simplify it, I would get 3/2 A, take away 3/2 B, and if I simplify this, well, if I factorize this, I'm going to get 3/2 brackets A minus B. So they are a scalar multiple of each other, and because they share a common point, M, they both start, one starts at M and the other finishes at M. So because of this, they go in the same direction and they have a common point. We can say that NMC is a straight line. So we can say
they also share a common point, and we can say, therefore, that it is a straight line.
And we've proven it. Okay, so the first part is to find AB in terms of the vectors A and B. So we can't go directly from A to B because there isn't a vector given directly from A to B. What we can do is go from A to B, we can say is equal to, well, we can go from A to O first, and then go from O to B. So A to O, we're given that, well, we're given that O to A is the vector 2A, but because we're going against that direction, we're going this way, we need to take the negative of that. So there's going to be negative 2A. And then O to B, well, we're given O to B is going to be 3B in that direction, in the same direction that we want. So we can say, well, A to B is going to be negative 2A plus 3B. It doesn't matter if it's 3B, take away 2A, it's the same. And part B, so part B, it now says that P is on the point AB, such that AP to PB is in the ratio 2/3, 3, sorry. So 2 is there and 3 is here. Show that OP is parallel to the vector A plus B. Okay, so if we want to show that it's parallel to the vector A plus B, we need to show that so O to P, the vector, is a scalar multiple of this. So let's find the vector O to P. So O to P, we are going to go from O to A first, and then A to P, or go from O to B first, and then B to P. I'm going to go from O to A, and then A to P. I'm doing this because it'll be easier for me, because I know that we have the vector A to B already. So if I'm going to go, if I go on the other side and go O to B, and then B to P, I know I need to work with negatives at some point, which I don't really want to. So I'm going to go from O to A, and then A to P, which is on the same direction as our part A. So O to A, we know is going to be 2A, it's given in the question. And then A to P, we can write it a bit differently. We don't have A to P the vector, but what we do have is we have the vector AB, A to B. And we know that A to P is going to be 2/5 of the way, it's going to be 2/5 of the way to A to B. Because in the question it's given us that AP to PB is 2 to 3. So I know that A to P is going to be 2/5 the way A to B. So we continue that. So 2A plus 2/5 of A to B, which is now going to be negative 2A plus 3B. So I've just taken that from the part A that we found out earlier. So 2a plus, so it should be negative, take away 2 times negative 2. So 2 times 2 is going to be 4/5 of a plus 2 times 3b, so 6/5 b. And this will be 6/5 of a plus 6/5 of b. And if I factorize this, then I get 6/5 on the outside and a plus b in the brackets. And I can quite clearly see that there's a common vector there, a and b. And we've shown that O to p, because there's a common vector, O to p is a scalar multiple of that vector there. So we've shown that it's parallel, just a different length, different size, but it is parallel, and that's proven. Okay.